All right, hello everyone. This is lesson number 48 on inverse variation. This topic is not necessarily, well, it's not really connected to any other topic that we've done. It's kind of isolated on its own. So it's not connected to what's before it, or it's not really connected to what we're going to do after this, just heads up. Before we get started, I thought it'd be good to do a brain teaser. It's been a long time since we've done one, and something I like to do in class to kind of get you to think and problem solve. So take a minute and try this problem. The question is, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 matches. The question is, move 3 of them so that the pattern points down instead of up, meaning that your matches are like that, same 10 matches, just pointing down instead of up. So you can pause the video and try it if you'd like. And then I'm gonna do the answer here in a minute. So if you don't want to see the answer, pause it and you can try it yourself. Okay, so what you should have done, well, there's several ways to do it, but one of the ways that you can do it is you can move this one here. Oh, let me put that here. And then you can move this one here. And then you can move this one here. So that's 3 movements of matches, and then you have that triangle pointing downward. So that is how you do that with 3, just to get you thinking a little bit. Okay. All right, let's talk calendar. Last week you had the review from the 5th 6 weeks. We reviewed the topics that we did there, mainly rational functions, and we only had 1 lesson that week. This lesson here is inverse variation. We had traditionally, since we started online learning, been doing 2 lessons a week, and in the past 2 weeks we've been doing 1 lesson a week. I decided to just keep with the 1 lesson a week, so we'll just stick to that. And so I'm just going to move this here. I don't think anybody has any objections to that, but if you do, let me know. I want to keep a balance of making sure you don't feel overwhelmed, but also making sure you're still learning, right? And so if anyone feels like it's not enough learning for you, just let me know, and I can provide some supplemental material, but just want to keep a balance. So I'm going to move this here. We actually only have 3 new topics to cover, and then we will have covered all of Algebra 2 material. We were ahead of schedule when we were in the regular, or in the last 6 weeks. So we're going to move the laws of exponents here. We're going to move this down here. And so we'll just have inverse variation, which is this lesson for this week. We'll have laws of exponents Monday for next week. This one will be down here. And then these last 2 weeks will be review, in which we're going to just review the topics that are most important to set you up for when you come back to school in the fall for pre-calculus. That's going to come back up. So we're going to focus on those for the last 2 weeks. But that's where we are. I sent a message, an important update with respect to school closures via Remind. And I'm sure by now, as you watch this video, you've all heard. But just in case if you haven't, it's official that schools in person will be closed for the year in the state of Texas, every public, private, and charter school, which means we won't be returning to Townview this year, which, as I said in the message, it was sad to me to hear that, just given that I don't want to really end the year like online, and I don't really get to say bye to y'all, or don't really get to have any sense of closure, and that's kind of sad to me. And knowing that I won't see y'all again in my class, you all are always welcome to come back and see me and say hi, and I love to hear how y'all are doing. But just not being in my class together, that's a sad thing for me, because I do miss you all. But it is a comforting thing to know that your safety is being taken into consideration. And also, I think if it's any comfort, I know there was always the question marks, like, are we returning? When do we return? If so, a lot of question marks. I had those at least. And I think it's good to have some sense of clarity, and it kind of may clear up some anxieties with respect to, like, what is really happening. Because I know a lot of us were kind of questioning what is the next steps here. And so at least that gives us some clarity with respect to that. But it's going to be a long time that we won't be together. I know many of y'all miss your friends, miss just being social in general, and that's real, and we're gonna have to grieve that a little bit. So let me know, and I'd love to hear from you in the comments here. How do you feel about that now that we know we won't be returning to school for this semester? And just heads up, that does mean that learning would still would still continue for DISD online. You still have grades and things of that nature. In terms of when the school will end, as soon as I find any more information, I'll share that with y'all. What testing will look like, if we will have testing, all of that information. As I get information, I try to update y'all regularly so that you're not out of the loop with accurate information, not misinformation. So just an update there, but we'll go ahead and get started. We will learn math, build character, never give up, and ask why. All right, let's jump into it. So the topic is inverse variation. Just kind of want to make a connection to direct variation, which is something you did in Algebra 1, which I know may have been a while for many of y'all, but you may or may not remember this. But I want to just do a direct variation problem real quick, and then we'll do inverse variation because it's a continuation of that, okay? So here's a problem. It says the cost of tacos varies directly. So I just want to be clear. This is not the lesson for today in terms of the topic for today. Sorry, this is a topic from Algebra 1, direct variation here, but I need us to make sure we remember this before we get to inverse variation, okay? So it says the cost of tacos varies directly with the number of tacos that are purchased. You are buying some street tacos from Tacos La Banqueta, and tacos cost, or 5 tacos cost $10. I don't think that's actually the price there. I think they're like $125 or $150. If you've never been to Tacos La Banqueta, it's really good tacos. They're in East Dallas if you aren't familiar with them. But so let's say that they cost $10 just to make the math easy here. So what makes this direct variation is the fact that the cost of tacos and the number of tacos are directly related. The more tacos that you buy, the more that it will cost you. That's a true statement, right? So if we're calling X the number of tacos, as X increases, or as the number of tacos you buy increases, Y, which is the cost of tacos, would also increase, right? So by definition, for direct variation, as X increases, Y increases. Or as X decreases, or the number of tacos you buy decreases, your Y would decrease, the cost of your tacos would decrease, right? So that's just what direct variation is. So we can see here if 5 tacos cost $10 and 1 taco is $2, right? So if we buy 3 tacos, if each one is $2, then the cost would be $6. If we buy 4 tacos, the cost would be $8. If we buy 5 tacos, the cost would be $10 here, right? And so direct variation is always going to have a constant, and that constant is going to be how much each taco costs, because that's the thing that's staying the same in all of this, right? The number of tacos can change, the cost of the tacos can change, but the constant is the amount that each taco costs. So in this context, our constant is 2, because that does not change, okay? So based on that, what that means is, if we were to write an equation for this, I want you to you can pause the video and think about what would your equation be with the relationship between these. Okay, so what you should have realized is that the equation should be y equals 2x, which is in slope-intercept form, right? Because let's say we try 4, 2 times 4, because 4 is x, that will give you 8, right? Which is the number of tacos. Or let's say you try 5. 2 times 5 would be 10, which is the y, which is the cost of the taco. So the relationship between the number of tacos and the cost of the tacos would have an equation y equals 2 times x. That's direct variation. That's what you kind of talked about in Algebra 1, just to kind of refresh your memory. So let's look at an example of what would be inverse variation, okay? So inverse variation, this is an example here. Let's read it. The time it takes to drive to Houston varies inversely. So this is a key word here. It says varies inversely. That tells us it's inverse variation. So it varies inversely with the speed you are driving. If you drive at 100 miles per hour, it will take you 2 hours, okay? So hopefully you're not driving 100 miles per hour to get to Houston, by the way, but apparently they're building in side note. Apparently they're building a train that goes from Dallas to Houston. It's gonna take a while to build, but I don't know if y'all heard about that. But that's kind of crazy. Where you can like have a day trip to Houston and get there really fast and back in the same day. But anyways, so in this problem, let's say, let's look at the first sentence. So it says the faster your speed, the less time it will take. So is that a true or false statement? If you're driving faster, that's true. It will take you less time to get there, right? Okay. So the difference here is, and let me define x actually first. So let's say x is going to be our speed. I'm sorry. Let's make x time. Sorry. And y is going to be our speed. Okay. So as x, which let's say x is time. So as time is going to be increasing, what's going to be happening to your speed? So if you're taking more time, then what's happening to your speed? Is it going to be faster that you drove or slower that you drove? If you're taking more time to get somewhere, it should be slower, right? If you're taking more time, you're driving slower. So in this context, if we're saying x is time, as x increases, or as time increases, so if this is 2 hours, 4 hours, 5 hours, to get to the same place, to get to Houston, if it takes us more time, then our speed should be slower. So y should be decreasing, right? If we are taking less time, or if x is decreasing, then if we're taking less time, then we are driving faster. So our y would be increasing. So these are the opposite. As x increases, y decreases, or as x decreases, y increases. So that's different than direct variation, whereas x increases, y increases. Okay? So that's the difference there. So let's talk about some of the numbers we have here. So we said if you drive 100 miles per hour, it takes you 2 hours, right? So 2 hours, you're driving at 100 miles per hour. So let's say it takes you 4 hours to get to Houston, right? You're taking twice as long. Well, then in that case, your speed would be half, right? You're first off, you should realize that you're going to be going slower, right? Because you're taking longer, and you're taking twice the amount of time, so your speed should be twice as slow, or half slow. So 50 miles per hour, right? Now, let's say you took 5 hours, so you're taking even longer. Your speed should be even slower than 50. But how much slower? That's not necessarily so easy to tell, just without doing some proportions there, right? So here's how you want to think about it. You have to think about your constant, okay? So this is thinking kind of in terms of physics. If you think about what's the relationship between distance, time, and speed, you can pause the video and kind of think about that. So your distance, or let's say your speed, is what we're looking for, right? And we have time, and we need our constant. So here's how we can think about it. What's remaining the same when we're driving from Dallas to Houston? The distance, right? The distance is always going to stay the same. The distance from Dallas to Houston is not changing. So distance is equal to time times speed. Distance is equal to time times speed. Okay? Here's one. Let's say, for example, in this first case, you have 2 hours and you're driving 100 miles per hour. If you're driving 100 miles per hour, that means that every hour you're driving 100 miles. That's why it says miles per hour, right? So if our speed is 100 miles per hour, and the time it takes us is 2 hours, when we multiply that, it should tell us that our distance is 200. That's the distance in miles, because distance is speed times time. Just thinking about it intuitively, 100 miles every hour means in the first hour you've driven 100 miles. In the second hour you've driven another 100 miles, right? So when you add up those two, it gives you 200 miles, right? So the total is 200 miles. So your constant there is going to be 200 in this case. So you would multiply these two to get your constant, because distance is time and speed. So here, if you see this here, 4 times 50 is 200 as well. So then you're looking for 5 times what is going to give us that constant distance of 200. And 5 times, or in other words, if you want to work backwards, you could do 200 divided by 5, right? So that's what's going to give us. So in that case, it would be 40. So 40 miles per hour. Because 5 hours times 40 miles per hour is 200. Okay? So now, what would our equation be here for the relationship between y and x? So it would be, and this is always the general form, it's y equals k divided by x. That is the inverse variation equation. Y equals, so in this case, our k is what? Our k is 200. So 200 divided by x. That is the equation for inverse variation. K over x, k being the constant. And then this over here, x times y, this is just, if you think about here, if we're saying this is x and this is y, x times y, time and speed, equals your distance, which in this case, distance is our constant. So k equals x times y. That's always going to be the case. And you can go between these two formulas by just dividing, right? Like if you divide by x and you divide by x, you get y equals k over x. So they're just related like that, okay? So the main thing to keep in mind here is that for inverse variation, you multiply x and y, it gives you your constant that's not going to change. And for your formula, use the formula y equals k over x, okay? So let's try that just with some numbers, and then we'll try another word problem. So let's say we have this problem. It says y varies inversely with x. So automatically it's inverse variation. This tells me that right here. If y equals 10 when x equals 2, what is the inverse variation equation? So the only information we have is that y varies inversely with x, which means as x increases, y decreases. As x decreases, y increases. They're going to kind of relate oppositely. And we know that y is 10 and x is 2. So the first thing we need is to find k. What is the constant? And k is equal to x times y. So we just do k equals x times y. So k equals, our x is 2, times y, which is 10. So k equals 20. So that's your constant. And the question is asking for the inverse variation equation. We have k of 20. This is the equation, so it'd be y equals 20 over x. That's the equation that you could use to find the relationship between any x and y. So that's it. So let's say here it says, what is y when x is 5? So then you have your equation here. You would just plug in 5 for x. So y equals 20 over 5. So that'll be y equals 4. So what is y when x is 5? If they're inversely related, it would be 4. And you can double check that because this times this should equal 20, right? 5 times 4, which it does. And that's the same thing that this times this equals. Okay? All right, let's try one more. What is x when y equals 2? So in that case, we're still using this equation here. You could plug 2 in for y. So 2 equals 20 over x. And you solve for x. Now in this case, you could just think, okay, 20 divided by what number is 2? And it would be 20 divided by 10 is 2, right? So x is 10. If you wanted to solve it out algebraically, if the number isn't clean like that, you would be multiplying by x first to get rid of the fraction. that would give you 2x equals 20. And then you would divide by 2 to get rid of the 2. That would give you x equals 10. It's going to give you the same thing, but just in case if the number isn't clean, where you can just see what divides. You can double check that because 10 times 2 should give you the same constant of 20, which all the other ones do. So 10 times 2 is 20, 4 times 5 is 20, 10 times 2 is 20, because they should have the same constant when you multiply them. So that's inverse variation with respect to just numbers. So let's look at a word problem. So this one says, every year the Wins host a family picnic. They know that the cost for each person varies inversely. That's a key word that tells us inverse variation. As the n, the total number of people who attended the picnic. So because this is inverse variation, that means as one of these increases, the other decreases, right? In this case, because it says the cost varies inversely as n, we're going to think about this as y varies inversely as x, okay? Just for the sake of understanding the relationship with these formulas that have y and x. So that means as the number of people increase, the total costs for each person, that's important, that each person is going to decrease because they're splitting it with each other. So if you have more people to split it with, then it's going to be less for each person, right? If the total number of people decreases, then the cost for each person would increase because you have less people to split the cost with, okay? So it says when 20 people attended the picnic, the cost for each person is $50. Which equation correctly relates the cost for each person to the total number of people who attended the picnic? So first we need to figure out what is the cost for the picnic in general. So that's the constant, the k. So k equals x times y. So it would be k equals, we have our x, which I'm saying that x is the number of people. And in this first case, they said when 20 people, so we're going to say 20 times y. Y is the cost for each person, which is 50. So that means our constant is 20 times 50, which is $1,000. Right? So that is our constant. So based on that being our constant, then what we can do with that is we can take that 1,000 and plug it into the formula that we have here for k. So it would be y equals, we know our k is 1,000. That's our generalizing the equation, over x, right? And y we said was c, so we can say it's c. And x we said was n, so we can say this is n. So 1,000 over n. That's a general formula that you can use to determine, no matter how many people you have, how much would the cost for each person be. So that's why the answer would be C here. So if it says how much does it cost for 50 people to attend, then we would be plugging 50 in for the people, which is n. So C equals 1,000 over 50. So that would be $20 per person. All right, which you can see here how this 50 is more than 20, so it's costing less money than it did there, which should make sense intuitively. So that's how you would solve that problem. All right, let's have you try 2 of them, just to make sure you feel comfortable. It's a pretty easy lesson, short. So take a minute, pause, try this one. All right, so what you should have done is first found k. K equals x times y. So your k is this times this, 5 times 25. So your k is 125. And then you're finding what is the value of y when x is 10. So the general equation is y equals 125 over x. So you're going to be plugging in 10 for x. So y equals 125 over 10. which you could either leave like that or you can write that as a decimal, 12.5. Okay? Hopefully you got that. All right, try one more in the context of a word problem. All right, so it says the volume V of a gas is inversely proportional. So that's a key word there, inversely proportional, to the pressure on it, P. If the volume of a gas at a constant temperature is 13 liters at a pressure of 45 millimeters, which formula can be used to represent this relationship? Okay, so this is saying like if our volume increased, then the pressure that we had should decrease, right? So looking at this, or really this will be easy, we just have to find K. So K is this times this. So that would be 585, right? That's your K, and then your equation is y equals K over X. So it would be y equals 585 over X. And then using the same variables I use, it's y varies inversely with X. So if this is y and this is X, it would be V equals 585 over P, which would be A. So that's it, really. So that's inverse variation. Again, this is kind of a standalone topic, but it is in the Algebra 2 curriculum, so just wanted to make sure I teach it to you. In terms of practice, so on the practice, I posted on Google Classroom. You can do it on, if you're able to print, you could print. If you're not able to print, you could do it on a sheet of paper. But if you could try to keep the paper as organized as the actual practice is, just so it's easy for me to grade. So here's what you would do. The actual question says to choose 4 out of 5 in different sections. And then some of them say choose 2 out of 3. I want you to do all of them, though. And so basically, here's how it works. This is the front side of the paper. This is on the back side. I just cropped out a part of it so you can see. It's just one practice. So what you would do is you would solve each problem. So I'm just solve one so you can see. It says each variable varies inversely with X. So let's say you're solving this first problem. If P equals 12 when X equals 5, find P when X is 10. So I would find K, which would be 12 times 5. K would be 60. Then I would use a formula, which would be Y equals 60 over X. And so it would be Y equals 60 over 10. So Y would be 6. So my answer is 6 there. And so then on the back, you would make sure that your answer is there on the back. On here, which it is not. So maybe I did something wrong. Wait, am I missing 6? Oh, okay. So this says, I'm sorry. So this is saying, this is right. It just says it tells you the population. So you're trying to figure out what country this is talking about. I think we've done one like this before. So this is saying the population in millions of this country is 6. So under population, you would put 6 million. And then you would keep going. This would tell you once you get your answer in billions, like let's say your answer is 5 billion, that would say the GDP of that country is 5 billion. You would write that under GDP. And then some of the bottom ones would give you one of these answers, and that would tell you different information about it, like what currency it uses or what continent it's in, things like that. And so your final answer would be like, this is a country here. You would write the country here. Like let's say the country was Venezuela. I'm biased because my wife is from Venezuela, and I would just write that there if that's the answer based on all the information you give, right? So that's what you would do there. But you would make sure you answer each of the questions, and then you write your final country based on the information you have. So that's it. It should be easy practice. This was an easy lesson. Let me know if you have any questions. Feel free to shoot me a message on Remind for anything. I'm always available. So y'all take care. All right.